Here we're going to go over some of the basic formulas from early math, and remember that formulas are patterns for how to solve a problem. So they've already done the solving of the problem. All they're doing is giving you the pattern and making sure you can stick it in. So once a formula is given, oh, that's nice, then you get to stick it in. So here are 5 formulas with what they mean. So this is rate times time equals distance. So rate times time equals distance. Oh yeah, that's good. So they may say, hey, rate is 5 miles per hour, time is 3 hours, and they'll have you find the d. So let's make sure we can do that. Stick the 5 up in for the r, stick the 3 right up there for the t. That's called substitution. 5 times 3 equals your d, and you end up with 5 times 3 is 15, gives you the d right there. Here's another one. We've done problems where we had to do sales tax on a purchase or increase or decrease of something. Tax on the rate of tax and the purchase price, the purchase amount. So if we know that our purchase amount is like $50 and the rate of tax is say 6%, then we take and use this formula to compute what our actual tax is. We take the $50 and put it right in there, substitution, and this guy, which is 0.06, goes right up there for that one. So the end tax amount will be 0.06 times 50. And if you do it by hand or on a calculator, you end up with $3. So that's the sales tax amount, which would then be added into the price if necessary. This next one is one that will convert degrees from Fahrenheit into Celsius. So if we say Fahrenheit and Celsius, Fahrenheit 41 degrees, what's the Celsius? They've already figured out how to do that. All you have to do is take and stick the 41 right there. So you get Celsius degree is going to be 5/9 of 41 minus 32. And then this becomes an arithmetic problem now that you've stuck in the Fahrenheit one. 41 minus 32 is 9. 5/9 of 9, that equals 5. So 5 degrees Celsius corresponds with 41 degrees Fahrenheit. Isn't that pretty slick? Simple interest formula right here. They say, how much interest do I get? That's a question mark. If my principal amount, which is the starting amount, is $4,000, and it's on simple interest, which interest rate is, say, 3%, 0.03, or they might write it as 3%, and the time is 5 years. And so we stick these guys in. I is going to be 4,000 times 0.03. That kind of looks weird having 2 dots, so I'll put parentheses around that one, times 5. And then multiply those together, and that's what we get. So that would be 4,000 times 0.03 times 5 gives you $600. You can times those out on a calculator or by hand. You should get $600 in interest that comes out. Good. Here's a money formula. Now, we don't often stick things in these formulas like this, but we actually do that. Look at this. If you take the number of quarters times by 25 cents, look, that's 25 cents times the number of quarters. D is the number of dimes, or you could have pennies or nickels on here. Number of dimes times 0.10, that's 10 cents, and then we end up adding them together. So if we had 7 quarters and the number of dimes is, say, 17, watch what happens. We stick it right up in there, and we get the total value of money is going to be 25 cents times 7 plus 0.10 times 17. We just stuck that guy right up in there. There we go. So 7 times 25 cents, that's $1.75. And really that's just 7 quarters. And then $1.70 for 10 10 cents for every dime. That's 17 dimes, $1.70. And we just add those two together and we get $3.45. Now, many of you will think, well, why do we need these formulas if we already know how to do it? Well, you don't. If you already know how to do it, then you certainly don't need to do that. Practicing these formulas will make it a lot easier when you choose to head back. Let's look at some of the formulas from geometry now. All right, so here are some of the formulas that happen with shapes in geometry. So if we look at this rectangle, now this is not sufficient in and of itself. It needs this kind of instruction. Perimeter. Now perimeter is a very interesting word. This means peri or around. It's a prefix saying around. You have a pericardium around your heart, and periscope looks all the way around, and this one means measure. So this is the word for a round measure. So the perimeter is going to be adding an L and a W and another L and another W all the way around. So that's where we get two lengths and two widths. And L just stands for length and width. So if they were to say, what's the perimeter of a rectangle if the length is 5 inches and the width is 6 inches? So you'd stick those in. Even though it's not such a tough problem just to add them up, it is a pattern where you'd stick a 2 times 5 plus a 2 times a 6, 10 plus 12, right on. Perimeter is then 22. Area is length times width. Now notice that when you do that, you're taking the length timesing the width. And so you actually get the entire thing filled in with little squares. And that's a fascinating thing, the square inches. So same thing, if you had, what is the area now if the length is 5 inches and the width is 6 inches? Well, you're going to times them. 5 times 6 is 30, certainly. But notice it's no longer inches. These things aren't inches, they are little inches that are squares, and we call those square inches. So the area would be 30, and you do inches times inches, or inches squared. And yeah, an inch looks like this. And an inch squared looks like this. It's a square inch by inch. This is what it measures area, and that measures a length going around. So that'll be good when we get all the way down to the three-dimensional stuff and start doing volume. So let's pick another one like this. So the perimeter here is whatever number this is, plus that one, plus this one, plus that one. That's just a round measure. Here, good heavens, we don't even label those. It's just you have to add up the three sides. There's no simpler way to do it. Notice the area of a triangle is exactly half the base times the height. That's kind of an interesting thing. Base times height would normally give us a rectangle like that. But you'll notice that we're half of this side of the rectangle and half of that side of the rectangle. So that's how we get that one. The area of the trapezoid, you've got quite a few things to stick in here. The big base on the bottom, the little base on the top, the height, and then 1/2 of that. Anyway, these formulas will, people have already worked for centuries to come up with the patterns of how to find the areas. You don't have to reinvent the wheel. They've already done it and given you the answers. All you have to do is stick the A in the right spot, the B in the right spot, and you'll get the right answer. Let's look at some others. All right, here are some others from geometry. Well, a rectangular solid, this is a 3D object. Notice that we now have SA. SA, what does that stand for? Anytime you see a formula, this is what should happen. They should tell you what these things stand for. Now, length and width and height are certainly things like that. Notice what's going on here is that this is the area on the surface. This is a 3D object now. You can't just find a length or a width or height and tell you everything about it. When you do this, this is saying you've got to take the length times the width, and that'll give you the area up here, and then you've got the area underneath. So that's 2 length times widths on the surfaces, plus the width times the height, that's this guy over here, and on that end right there, plus the guy on the front, which is what, length times height, that's a rectangle, and then on the back. So that's this guy over here. So you actually have 6 different faces on here, and you have to find the areas of them. So this is the summary of how they got that. Now, all of this is area, which means if these guys are in inches, then area is going to be in inches squared. Okay, that's an inch. That's an inch square that covers the area on the outside of the box. Volume, however, Oh, this is interesting. Volume is a three-dimensional object. When you take the length times the width times the height, let's do it over here. We don't know the volume. If the length is, say, 3 inches, and the width is, say, 4 inches, and the height is, say, 5 inches, when we times all those together, 3 times 4 times 5, volume is going to be 60 inches. Let's write that out. Volume is length times width times height. 3 times 4 times 5. That gives us 60. But notice we've got inches times inches times inches. That's inches to the third power. That means inches have made a little cube of themselves. Look at that. That's a cute little inch cubed. And that guy right there is how we measure volume. It could be in feet cubed or centimeters cubed, but this 3 up here makes us aware that we are measuring a three-dimensional property of this. So areas are two-dimensional properties because they have length and width, or width and height, and volume is you're measuring now a three-dimensional object. All right, so look at this. A standard geometric circle that's been around for centuries. People have studied circles forever. Object that's very common. Well, they found out that going around the outside of it with its perimeter, now look at this, circumference. All this is, circum means to go around, measure. These are just the exact same perimeter and circumference. They're the same word, just with two different roots of being a round measure. So they actually found that if you had a circle this big and you went around it, and then you went across it, all the way across it, and divided those two numbers, the circumference over the diameter straight across it, you got a number just about 3. Well, it's a little bit bigger than that. Even if you had a huge circle and then went all the way across it, and you took the circumference divided by the diameter, you got 3.14, and it kept going. Well, that's where the number pi comes from. It happens out in nature. We didn't even make it happen. But once we found it, you can actually stick it in on your calculator. And going around, you take the radius, double it, and then times by that pi number, and you will get exactly the circumference. The area is a different ball game. The area, if the radius is, say, 7, so 7, when you do pi times 7 squared, 7 to the second power, area would be pi times 49. And you'd punch this in on your calculator, or sometimes your math teacher will have you leave it like this, and you are actually finding the number of squares. So if you were to crisscross this with actual inches, you're finding the area it takes. And notice you're going to get a decimal because not all these guys come out evenly. But yeah, it'll be a decimal, but that's the exact number of squares that it will take to cover the entire circle. Cylinder. Oh, shoot, this is like a 3D circle. But notice the top, if you're going to find the area, is pi r squared from right here. And the bottom is pi r squared from right there. And then if you were to do the outside of it, well, let's look at it like a can. Slice the can right in half, or right down the side, like that. And, if it goes like this, and we start unpeeling it like that, and then we peel it all the way out, that's nothing more than a rectangle. And the height is the height, but ooh, this guy right here, that's going all the way around here. That actually comes from that formula right there, 2 pi r. So we go back up to the rectangle one, and you have length times width. So this guy has area 2 pi r h. So if you want the lateral surface area, notice this, lateral surface area just on the sides, it comes out to 2 pi r h. That's where it came from. Now, you don't actually have to know where it came from. All you've got to be able to do is stick r in the right spot and stick h in the right spot, and the formula will give you the lateral surface area. But if you want the whole area, you have the lateral surface area right here, and then you have a pi r squared on top and a pi r squared on the bottom, and this is where they got the total surface area, the surface area on the whole cylinder. Fascinating where they come up with these. And volume, pi r squared h. Well, they took pi r squared in the bottom. That's an area, and then they times it through to the height. So they filled in this whole thing. And again, if height is in like centimeters, then these guys are going to be like centimeters squared. So little square patches that are going to cover the whole outside. Centimeter squared, this is an area. And volume will be centimeter cubed. Bingo. And so that's how you do it. You just stick in the numbers, R in there, H in there, and you come out with volume. That should give you a rough idea of how to use formulas with geometry.